Hey everybody, welcome to chapter 9. This is the final chapter of this year for Algebra A. You guys have made it to the end. Only a couple more lessons to go and we are done for the year. This is chapter 9, section 9.1, Introduction to Quadratics. As always, feel free to pause if you need to catch up, you're falling a little behind in terms of the work from the video to what you can write on the paper. Just move at your own pace. The do now asks, which expression is a quadratic polynomial? Well, the word quadratic, right, means the highest exponent in the polynomial is 2, or squared. So I'm going to look at the highest exponent from each one. And this first one doesn't even have an exponent. That means it's a 1. No good, no good, no good. Your only quadratic is option D. X squared minus 2x minus 2. Now, quadratic functions, they're a little different than the linear functions we've dealt with for majority of the year. A quadratic function is in the form y equals ax squared plus bx plus c. Just remember, a, b, and c are placeholders for actual numbers. Two things to remember is if a, the a term, meaning the number in the front, which is this one right here, is positive, your parabola opens upward. So think, positive, smile. If a is less than 0, the parabola opens downward. So think, negative, frown. You can see those here. Positive, negative. And that funny word parabola is the U-shaped curve that is the graph of the quadratic function. So these are called parabolas. So a linear function has a parabolic graph. Well, we've been dealing with linear functions all year, and we know the first part of that word is line, so this is false. Linear functions have straight lines as graphs. The path of a basketball free throw shot has a parabolic shape. Well, if you're shooting, right, here's the ball, you're going to shoot the ball up, and it's going to come back down into the hoop. So, to me, this looks very parabolic. I would say true. And a parabola that opens upward passes the vertical line test. Well, the vertical line test was something we used to determine if a graph is a function. So if you have a parabola that opens upward, and I was to draw vertical lines, all of those vertical lines only touch the parabola one time each. So yeah, that's true. It passes the vertical line test. It is a function. Identifying a vertex. What is the vertex of the graph? Is it a minimum or is it a maximum? So the coordinates of the vertex, and just write what it is under here, that's the turning point. That's where the graph changes direction. So if you have a positive quadratic, your vertex is at the bottom. If you have a negative quadratic, your vertex is at the top, which is what we call a min and a max. So the coordinates of this vertex in the graph on the right-hand side is right here. And that's at the point -2, -3, so choice C. The vertex is at the lowest portion of that graph, so we call it a minimum, because there's no part of the red line that is below the blue point. All right, so identifying a vertex, very easy. Just look for that corner where it changes directions. All right, graphing y equals ax squared. Graph the function y equals -3x squared. So they're giving us a bunch of different values for x, and they want us to plug those in to the equation. So go ahead and fill them in. -2, -1, 0, 1/2, 1, and 2. Okay, so now all you have to do is simplify. So -2 squared is 4, and 4 times -3 is -12. So your first point is -2, -12. -1 squared is 1, times -3 is -3. 0 squared is 0, times -3 is 0. 0, 0, the origin. 1/2 squared, so 0.5 squared is a quarter, or 0.25, and 0.25 times -3 is -0.75, or -3/4. 1 squared is 1, times -3 is -3. 2 squared is 4, times -3 is -12. And what do you know? The graph sort of bends back around. You have a -12 and a -12, a -3 and a -3. And that's how you create that parabolic shape that we've been talking about. So on the next page, or on the bottom of your page, they want us to determine which of the graphs is the correct one for this table that we just completed. So we're looking for -2, -12, which actually goes off the page because we don't go that far down. It only goes to -8. So we're looking for -1, -3. Left 1, and that's at -2. Left 1, and here's -3. And you can check the other points, the origin, 0, 0, 1, 3, and 1/2 and 3/4. So here's your graph for y equals ax squared. The other ones do not have the correct points. And it says circle the domain and underline the range. Well, the domain is your span of x's. And as these arrows keep going down, they keep getting wider and wider and wider and wider and wider and wider as you go. So the span of x's is actually all numbers, all integers, I should say. But your y values, meaning the up and down portion, although they get lower and lower and lower and more negative, they stop at 0. So it's 0 and below. So it says underline the range. That's y is less than or equal to 0. Okay. So graphing y equals ax squared plus c, very similar. Again, they want us to plug these numbers in, these x values in, for x in each of these equations. The first equation is pretty simple. You're just squaring all of the x values. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So if we plot these points, negative 2, 4, left 2, down 4, left 1, down 1, 0, 0 is the origin, 1, look at me, negative 2, positive 4, negative 1, 1, 0, 0, 1, 1, 2, 4. So there is your parabola of the first quadratic equation. Now what they want you to do is plug those values in again for your second parabola, and we're going to compare what happens. So if you notice, they both have an x squared, right? The only difference is this minus 3 on the back end, and we're going to see how drastic of a change that creates. Negative 2 squared is 4, minus 3 is 1. Negative 1 squared is 1, minus 3 is negative 2. 0 squared was 0, minus 3 is negative 3. 1 squared was 1, minus 3 is negative 2. And 2 squared was 4, minus 3 was 1. So let's plot those points again. Negative 2, 1. So left 2, up 1. Negative 1, negative 2. Left 1, down 2. 0, negative 3. And then it comes back around. 1, negative 2. And 2, 1. Now it says explain how you can get the graph of y equals x squared minus 3 from the graph of y equals x squared. Well, if you notice, each respective point is just 3 down from its counterpart on the blue line. So you say move each point down 3 from y equals x squared. And that makes sense because this is x squared minus 3. Okay, this reasoning is essentially the same answer from the previous question. So how can you get the graph of y equals ax squared plus c from the graph of y equals ax squared? So you're going to move up this time because it's a plus c, right? And you're going to say move up c units. All right, guys, number 5 is the falling object method. An acorn drops from a tree branch 70 feet above the ground. The function is h equals negative 16t squared plus 70. Gives the height h of the acorn in feet after t seconds. So we have height h and seconds for t, or time. Now, although they're using h and t, that is the same thing as using y and x. This is really y equals negative 16x squared plus 70. Same thing. What they want you to do is they want you to plug in, just like we plugged in the x values before, which is essentially our t values in this given quadratic. So we have negative 16 times 0 squared plus 70. Negative 16 times 1 squared plus 70. Negative 16 times 2 squared plus 70. And negative 16 times 3 squared plus 70. All we have to do is calculate these to determine our h value, which in the past is usually the y value. Okay, so 0 squared is 0, times 16 is also 0. So at 0 seconds, the acorn is at still 70 feet above the ground, which makes sense because it has not fallen out of the tree yet. It's just hanging in the tree. 1 squared is 1, times negative 16 is just negative 16. 70 minus 16 gives you 54. Now the acorn is dropping because it went from 70 feet down to 54 feet, so we're slowly falling. 2 squared is 4, times negative 16 Negative 16 times 4 gives us negative 64. So 70 minus 64 only gives you 6. So now this is a drastic drop. From 1 second to 2 seconds, this acorn went from 54 feet in the air all the way down to 6. The last one, 3 squared is 9, so negative 16 times 9 is negative 144. Negative 144 plus 70 is negative 74. So that's interesting. So now we're negative 74 feet above the ground, which would mean that we're below the ground. Why would we not calculate the heights for any negative values of t? Well, when we get this negative 74 number, that means the acorn not only fell from the tree, it hit the ground and it went through the ground under the earth 74 feet. Now, I don't know about you, but whenever I've seen an acorn, they don't explode through the floor or the ground and go to the core of the earth. They lay on the ground at the top because it's just not strong enough to break through the ground. Why would you not calculate the heights for any negative values of t? Well, that's because it would have been below the ground. Circle the value of t that should not be graphed, so we're going to take off this 3 and negative 74 point. We don't have to graph that one. So what they want you to do is plot these points on the graph. 0, 70 is the acorn hanging from the tree. 154 is about here, so we're slowly falling from 0 to 1 second. And then it goes to 2, 6. 2, 6 is about here. And we know 3 was negative. So here is half. Whoops. Here is half of a parabola. So we only see half of our negative U-shaped figure. At what time does the acorn hit the ground? The acorn hits the ground in between 2 and 3 seconds. When is the vertex of a parabola the minimum point? When is it the maximum point? Well, remember, we said we have positive parabolas and we have negative parabolas. Positive, negative. Positive parabolas have the vertex at the bottom, which means it's a min. Negative parabolas have the vertex at the top, which means it's a max. I see a negative 5x squared and I see a positive x squared. Negative opens down, positive opens up. Make a conjecture about quadratic graphs, the direction of their graphs, and their maximum and minimum points. So that's basically taking those images I just drew at the top and converting them into words. Positive quadratics, negative quadratics, positive quadratics open up. They have a min. Negative quadratics open down. And they have a max. And there you go. That is the end of your first lesson of the final chapter. If you have any questions, of course, always email, Google Voice, reach out to me. I'm here to help. Thanks for watching.